The main excitatory neurotransmitter is going to be glutamate. All right, it induces postsynaptic neuron depolarization and calcium entry through the NMDA receptor. Okay, so your brain literally rewires itself when you learn. It's called long-term potentiation, and it happens due to the NMDA receptor. So let's just talk about this. Let's just iron this concept. So we have this hippocampal neurons, and that's where your learning and memory occurs. And repeated stimulation causes the stronger synapses to build, and glutamate will bind the NMDA, and that causes an influx of sodium and calcium. Okay, and then the NMDA receptors require depolarization to remove the magnesium block, and then the calcium is going to enter and it's going to trigger all these second messenger pathways, protein kinase C and several other ones, and they're going to do the little things. But the calcium surge is what causes that, and you can block this with ketamine and PCP, and also memantine that's used in Alzheimer. So let's do a practice question. A new medication is being tested. It's found to increase your calcium influx at synapses at the hippocampus following neuronal activation. Which receptor is most likely being targeted? Well, it's increasing the calcium influx, and so it's going to be your glutamate NMDA receptor. All right, so these are calcium permeable glutamate mediated ion channels. It's not going to be these guys. That's going to be your sodium low yield GABA that opens your chloride channels, causing hyperpolarization. So your GABA is a chief inhibitory neurotransmitter, causing postsynaptic hyperpolarization, and it does it by increasing chloride and your bicarbonate influx. Ionotropic GABA A ion channel. Alpha 2 adrenergic receptor. This is presynaptic. It inhibits your norepinephrine release. And your glycine receptor, that's going to be your chloride channel and inhibitory as well. So just to recap here, the high yield points, and your dopamines, your dopamine D2 receptor is inhibitory, and it's coupled with your GI proteins. Those are inhibitory. They inhibit depolarization rather than potentiate it. GABA B is a receptor that causes hyperpolarization of neurons, and that's through a potassium efflux. And it doesn't support potentiation, especially not through calcium. So that's why it's wrong. NMDA receptors, we talked about this, long-term potentiation, LTP, memory learning, calcium, sodium influx leading to depolarization to cause those downstream effects. Glycine is inhibitory, that increases your chloride permeability, leading to hyperpolarization as well. And so the glycine is definitely inhibitory. Dopamine can be excitatory or inhibitory, depending on the receptor subtype, by the way. Norepinephrine alpha 2 receptor is located in the presynaptic terminals, inhibiting the norepinephrine release. Okay, hopefully this is helpful. Just a lot of stuff about how this all works inside of the brain. So we'll see you in the next bit.